Okay. All right, so here we're going to solve equations that are in quadratic form. So these equations are not quadratic equations, but they do have a form that looks quadratic. So they have some quadratic characteristics. If we look at this first one, like x plus 1 to the 2/3 power, subtract x plus 1 to the 1/3 power, is minus 2 equals 0. So this is not a quadratic. However, it does have a certain likeness to like x squared minus x to the first minus 2 equals 0. It has that form. The only difference is instead of it being, x is x plus 1 to the, instead of to the 1 is to the 1/3, and x plus 1 to the 2/3. So here we're going to use a method called U-substitution to make these types of problems more, quadratic-like and simpler to deal with. So I'll show you. And you can see here they said, okay, instead of writing x, you don't want to put another x to confuse you. So instead of saying this is x to the first, that would be confusing because there's already an x. Here we'll say this is u, right? So then u will be x plus 1 to the 1/3 power. So then if I have x plus 1 to the 2/3 power, then that would be u squared. So I got u squared minus u minus 2 is equal to 0. Well, now we can factor this like a quadratic. Just like, you can say, oh, I got two sets of parentheses equal to 0, right? What's what can I multiply together to get u squared? Well, that's u and u. And then what two numbers can I multiply together to get -2? When I add together, I get -1, right? Because that's a -1u. So that's going to be a -2 and a +1. Now we can say u is equal to 2 and u is equal to -1. Now this is where we have to think about this a little further. We're not done. Instead, we're saying, hey, u is equal to 2. But remember, u is also equal to x plus 1 to the 1/3 power. So really we're saying x plus 1 to the 1/3 power equals 2. And we can solve from there. To get rid of the 1/3 power, that's really just the cube root. You would cube both sides, and then I don't have enough room to do it, but I'll do it. Let's see if I can do it over here. So x plus 1 to the 1/3 power, right? 1/3 power is equal to 2. And then we had another one, right? U equals -1. That means x plus 1 to the 1/3 power equals -1, right? Because u was set equal to both of those things, and we know u to be x plus 1 to the 1/3 power. So now, when I'm solving this, the 1/3 power, I tend to gravitate towards, radicals. So I personally would say, okay, this is the cube root of x plus 1 equals 2, and the cube root of x plus 1, you could say x plus 1 to the first power equals -1, right? And then I can say, okay, how do I take this apart? How do I get rid of the cube root? Well, if I want to get rid of the cube root, I do the opposite. I cube, right? Cube. What I do to one side, I do to the other. Cube. Same thing over here, same process. Cube. Cube. Now, the cube root and the cube cancel out, and I just have x plus 1 is equal to, 2 times 2 times 2 is 8. All right? And then that means x equals 7, right? You subtract 1. Over here you have x plus 1 equals -1 to the third is still -1. So then you subtract 1 and you got x equals -2. And now here's something to think about. Extraneous solutions. Here I raised both sides of the equation to the 3rd power. Now, if you've been paying attention, you've been following my videos, you got to know if you raise both sides of the equation to an even power, or if you take an even root, then that can open the door to extraneous solutions. But in this case, 3, we raised both sides to the third power, which is an odd power. So because we raised both sides to an odd power, it does not open the door to extraneous solutions. Therefore, I wouldn't check it. Now, I probably should. I'm a human, so I could make mistakes easily. But I'm just going to say, if you want to check it, you check it at that point. I'm saying x is equal to 7 and x is equal to -2. That's my answer. I feel confident. All right, let's go on to the next one. Let's try another one. All right, so the idea is we put this in terms of u. Instead of x, we're putting it in terms of u, but u has got to be equal to something. All right, so let's come over here. All right, let's look at example A. Oh, we just did example A. Haha. Now let's look at example B. All right, so we did example A. Let's look at example B. Now here, this, although it has more of a quadratic look, is not quadratic. Negative exponents means that the variable goes to the denominator, so this is actually a rational equation. And you could solve it, with a more rational style of doing it, but I'm not going to. I'm going to solve it with this same, what we call U-substitution. So here's how we go about it. I'm looking at this, and first I'll get it all set equal to 0. So 6x to the -2 plus x to the -1 minus 2 is equal to 0. All right, let's see if I can. We'll go for it. Yes, all right. So I'm going to say u is equal to x to the -1, right? So I'm always choosing that middle term. If you have it since it has this quadratic characteristics, right, it's always going to be associated with that, the linear term of a quadratic, or if you have it in the standard form for quadratics, then it'll always be the middle term. Or basically the term, if you have the powers, you'll have this one, which will be double that one, whichever the middle term, I guess, the B term, you might think about it like that. So now we have 6u squared plus u minus 2 is equal to 0. Much friendlier. Now I can think about techniques for solving this. I would say, all right, it's quadratic, right? Now it is quadratic. And to solve a quadratic like this, you got options. You can try to factor. You can do completing the square, or you can do quadratic formula. It's really up to you. I always tend to start with trying to factor. Since this has a leading coefficient that is not 1, my little factoring trick is to multiply this by the last term, and then I got u squared plus u minus 12 is equal to 0. Now I would say, all right, 2 sets of parentheses equal to 0. U times u is equal to u squared. And then I'm looking for two numbers that will multiply together to give you -12, but when I add them together, I'll just get a +1, right? The 1 right here, the 1, right? So I'm thinking 3 and 4. So the 4 needs to be bigger, so -3 and +4. Those two numbers, if I multiply them together, I get -12, and if I add them together, I get +1. So I know they're going to work. So, I can say, okay, got this 6 right here. Now, we use this little trick, and it created this 12. Now, in math, you got to hold a balance, right? I can't just be multiplying stuff by 6 because I want to. That offsets the balance. So now I have to compensate for that. Now, this 12 resulted in this 3 and this 4, right? That's how we got the 12. So I'm going to divide this by 6, and I got to do it to both of them because I did it and created the 12. Now I got to undo it, right? So divide them by 6 to keep the balance, and I got u minus 1/2, right? And then I got u plus 2/3. I simplify, equals 0. Now, these are not factors. They look like factors, but they're not. But they will help me to get the answer for u. So I say u, I'll just say minus 1/2 equals 0, right? We set it equal to 0, and then we solve. So u is equal to 1/2. And then u plus 2/3 is equal to 0, so then u is equal to negative 2/3. So now I have u, but I wanted x. All right, so what do? Well, coming back up here, and I'm saying, okay, I gotta know that u is equal to x to the negative 1 power, x to the negative 1. So if u is equal to 1/2 and u is equal to x to the negative 1, so x to the negative 1 is equal to 1/2. And then if u is equal to negative 2/3 and u is also equal to negative x to the negative 1, then that's x to the negative 1 is equal to 2/3. Okay, hopefully you're following me here. Now, x to the negative 1, that is, you can write it as 1 over x equals 1 over 2, and then 1 over x equals 2/3, right? If you don't know what I'm talking about here, remember, if I have any number with a negative exponent, I'm going to just put, I guess I could put a variable up there. All right, and then that would be 1 over a to the positive n, right? So that's the little property of negative exponents. So now I'm saying, okay, I just multiply both sides by x, multiply both sides by 2, and I have x equals 2. Multiply both sides by x, multiply both sides by, 3. So I'll do it over here, x and x, that cancels out, 3 and 3, right? So then I have, cancels over here, I have 3 equals 2x, divide both sides by 2, 3/2 equals x. So there you go. You should check your answers. It's probably pretty good practice to check your answers. Especially when you get these ones with negative exponents, you're saying that x can't be 0. So, I know my x is not equal to 0, right? Because what this really is saying over here is this is 6 over x squared plus 1 over x equals 2. And I know that, hey, x cannot be equal to 0 over here, or else you'd have a 0 in the denominator, which you can't do, right? We can't divide by 0. So I feel confident that these are the correct answers, but I would say, anytime you get into something new, you should always be checking. Just plug them into the original and see if they're correct. Okay, let's do one more. All right. Here, this looks, once again, it has a quadratic look to it, but it's a quartic function. Quartic might be 5. All right, it's a 4th degree. That's why we just start calling them degrees after cubing. What is it? 4th degree function, right? Now, when I look at this, I'm thinking it's not quadratic, but I want to use a quadratic tactic. So if I say let u equal x squared, right, the middle one. I want it to equal the middle term. Then, right, what do I have? Well, I have 12u. Now, let's think about this. If I say u is equal to x squared and this is x to the 4th, well, x squared, right? So u squared is equal to u to the 4th minus 11u plus 2 equals 0. And now we're doing the same thing we were doing a minute ago. Now it is quadratic, and we're saying, all right, it keeps going down. So now we're doing 2 sets of parentheses, set equal to 0, and we got, yeah, that's not the way to go to begin with, because I got this 12. We're going to try to factor, and I'm going to use my trick again and see if it'll work out for us. So we got u squared minus 11u plus 24 equals 0. All right, so let's see if it'll work out. I'm looking for numbers. I got u and u. right? And I want two numbers that I can multiply together to get 24, but when I add them together, I get negative 11. So let's think about this. 2 and 12, but if I add those or if I subtract them, I'm not going to get 11. So then I got, okay, 6 and 4. Add them together, I'll get 10. Subtract them, I'll get 2. So that's not 8 and 3, right? If I add 8 and 3, I'm going to get 11. So I know it's going to be 8 and 3. So 8 and 3. And it's always, you think about this. If they were both positive, they would give you 24, but then they wouldn't give you negative 24. So you need two numbers that will multiply together to give you positive 24, that when you add them together, you'll get negative 24. So they both have to be negative here. Negative 11. They both have to be negative, right? So now we have to undo our trick, right? We multiplied by 12, so now we got to divide by 12 to keep the peace. So both 4 goes into both of them. That's 2/3. 2/3, right? And then over here, that's 3 goes into both of them, and that's 1/4. So then U equals 2/3, and U equals 1/4. Now that's U, right? Well, we said U is x squared, so that means x squared equals 2/3, and x squared equals 1/4. Right, so now we can, take the square root of both sides. Now, taking the square root of both sides, right, the square and the square root cancel, and I got x. Anytime I bring up the square root, I made it, I got to put a plus or a minus, right? And then 2/3 like this. Same thing over here. X, square root over here, square root over here. X equals plus or minus the square root of 1/4. Now let's start with the 1/4. What's the square root of 1? 1. What's the square root of 4? 2. So plus or minus x is equal to positive or negative 1/2. All right, well, then over here, not as simple, right? Now, in math, you can't have a square root in the denominator. So really, what is this equal to? This is, plus or minus the square root of 2 divided by the square root of 3. So we have to do a technique called rationalizing the denominator, making sure you don't have a square root in the denominator, which means, well, what can I multiply the square root of 3 by so that it's no longer a square root? You can multiply it by the square root of 3 and do it up here too. So then you can say this is equal to plus or minus. Now that would be the square root of 6 all over 3. Now, that means there's 4 answers here. But let's think about something. I took the square root of both sides. Now you gotta be paying attention. Anytime now this is either you take an even power or an even root. Anytime you take an even root of both sides, of the equation, you open the door. The door, right? That's what I'm always talking about. Opening the door to extraneous solutions. What is extraneous solutions? We're talking about false solutions. Opening the door, does that mean all the time you're going to have them? No, it means the door was open. Maybe they came in, maybe they didn't. Either way, you got to check. So now I got 4 answers I need to check. And I would say, check them. I don't really have a great way of checking up here. So you're going to need to check those in your calculator. I would say just put them in your calculator exactly how you see them and see if you get a true statement. I'm going to check them, but since it's in my calculator, you won't see it. but I'm still going to check them. So let's walk through it. I got 12. I'm using my parentheses in my calculator, and I'm using the alpha, y equals enter, that green button, then the y equals, then the enter gives you that nice fraction bar. And I'm going to start with the square root of 6 over 3, right? Square root of 6 over 3. I'm going to put it in exactly how I see it. And then that's to the 4th power. Minus 11 parentheses, right? Alpha, y equal enter, the square root of 6 all over 3. And then that one is, that parentheses squared, and then plus 2. All right. What does that equal? I push equal, that's 0. So the positive version, that's the solution. Now let's try the negative version. I'm going to go back, I'm going to press up twice and select that whole equation. And now I'm just going to enter a negative sign in front of my square root symbol. And to do that, you let's see. Yep, you're going to have to, you can kind of do it all over if you want, but I prefer to highlight the square root symbol and then hit second, and then the delete button makes an insertion, and you can insert a negative right there. And then, even though, you know, since they're going to be, I shouldn't have even done that. Since we know an even power always makes for a positive answer, I already know this is going to work, because -6, you know, the square root of 6 over 3, that one worked. So the negative version, which means they're both going to be to an even power, is also going to work. So I know that's going to work. But I guess if you weren't thinking ahead, like I wasn't thinking ahead, then you wouldn't be sure. So now we're doing positive or negative 1/2. And now we're thinking ahead, right? So let me just go ahead and select one of them. And I'm going to say, all right, clear that out. And I'm going to say 1/2. It doesn't matter if it's positive or negative, because I'm thinking ahead. And I know that even if it's negative and I take it to the 4th power, then it's going to end up being positive. And if it's negative and I take it to the 2nd power, it's going to be positive. So that equals 0, which means the negative version will also equal 0, which means these are all valid answers. These are all the answers. I checked them. I feel confident. Man, we're great at math. Thank you. Have a great day. Practice these. Practice them.